Okay. Now, whoops. Just a couple of announcements. One, it's not a major one, but just something you might be interested in. I saw it posted on the wall out here. This coming Friday, I think it's a UAB theater department, is going to be presenting a Shakespearean play, modified somewhat, called The Taming of the Shrew. It's a comedy, so it's supposed to be pretty funny. And it's, they modified what Shakespeare wrote. He wrote the story of a sort of a wild, independently minded woman that this guy's supposed to be marrying, and he's trying to tame her, and it provides a lot of laughs. But the UAB production is taking the man as being the wild one and the woman trying to tame him. So I don't know how that's going to work, but evidently they think it's quite good. So it's going to be 10 o'clock Friday morning on the Birmingham East Campus in the A.G. Gaston Auditorium. The Taming of the Shrew. I don't know if you have heard about it or not, but it's I think a UAB production that is going to be there Friday from 10 till something another, and that's it's taken from a Shakespearean comedy, Taming of the Shrew, which, if you were as old as I am, you would remember that two of the most famous actors of my generation, before my generation actually, were Elizabeth Taylor and Richard Burton. They actually married a time or two or three or something like that. But they did the movie version of it, and it was supposed to have been, I never saw it, but it was supposed to have been quite a classic movie. And they both highlighted their skills and charms in that. So that's going to be Friday morning, 10 o'clock, A.G. Gaston Auditorium on the Birmingham East Campus. If you're interested in going, it should be pretty good. Okay? You don't get to see much Shakespeare here on Lawson State, so it might be worth it. Okay. Now, last time, let's see, only other things I can think of to say, my office hours, I think, are sort of stable for a while now, knock on wood. Monday, Wednesday, 3:15 to 5:15. Tuesday, Thursday, 1:15 to 3:15. Friday, 7:45 to 11:45 on the Birmingham campus. Monday through Thursday here. Okay. Now, I'm pretty certain of this. None of y'all are going to be around next year, right? Not here at Lawson, right? Not going to be here at Lawson next school year, are you?
Spring.
You'll be here in the spring, right, but not next fall. Yeah, probably none of you, right? Miss Geraci is trying to recruit for a math team well in advance of next year. They always put it off till the beginning of fall, and you never can get it together until right before the thing, so they didn't have very much practice time at all. So she said to recruit early. So I told her I'd tell my classes, but I figured y'all not going to be here by then. You'll be elsewhere, I'm sure. Okay, so let's move on. We had started last time talking about Euler's method and ways to proceed with numerical analysis, numerical solutions, you might say, of differential equations. Okay, here is the one, this is on page 78, example 1. Okay, consider the initial value problem, y prime, let me get my pen activated. Okay, y prime is equal to 0.1 times the square root of y plus 0.4 x squared, initial value y of 2 is equal to 4. It said use Euler's method to obtain an approximation of y at 2.5. So here's what we're looking for. Y of 2.5. Okay? Now, they say do it two ways. First, using h of 0.1. The second time, we'll do it h of 0.05. Okay? So, how do we begin? Well, maybe we ought to write down Euler's method. Okay? The summary of this is y of n plus 1 is equal to yn plus h times f of xn yn. Okay? All right. And by the way, the y prime, this is your f. This thing right up here. Okay. Now, where we begin is your x of 0 is 2, your y sub 0 is 4. Right? That's your initial value. That's your starting point. That's where we're going from. Okay? Now, where we're going from there, your y sub 0, we're going to do y sub 1 first. Okay? So your y sub 1 is going to be y sub 0 plus h times f of x0, y0. Right? Now, think about what this is doing. This thing here is your first derivative. Okay? You're starting with y, and then you're going, h is a little measure of x, and this tells you how far you're going from that y, so this gives you a new y. It also gives you a new x, right? So that will then be x1, y1, okay? Then we'll take this and go from there and keep doing. So that's what this is doing. Your new y is going to be your old y plus the change of y times a little bit of change of x. This is dy dx, that's what this is, and this is your change of x. So that's what is happening now. Rather than just seeing formulas on the board, that's what the formulas are telling you to do. Okay? So y1 is going to be, your y0 is what? Four. Plus, and which h are we using now? 0.1 times your f of x0, y0. Well, here's your f here. This is your first derivative, the change of y per change of x. And this will be 0.1. Now that's different from this 0.1. The h is this, and this is that. They just happen to both be, sorry. Square root of y, well, y0 is 4, so square root of 4 is 2, plus 0.4 times x, which is 2 squared, which is 4. Okay? So this should give us our new y, y1. So this is going to be 4 plus, and let's keep the 0.1 on the outside for now. 0.1 times 2 is 0.2, right? Not that hard. Plus 0.4 times 4 is 1.6. And that was the 1.8 we looked at last time, if you remember that. So this is 4 plus 0.1 times 1.8, and this would be 4 plus 0.18, right? So that is 4.18. So there's your Y1. Now what's your X1, by the way? The H is an increment of X, so you started at X equal 2, and you went to X equal 2.1. So the 0.1 tells you how much you change your Y, your X. This is your new Y. So now, your Y2 is equal to Y1, which is 4.18, plus, and your H is still the same, 0.1 times 0.1 times your square root of 4.18. Now, I'm going to write it down that way. That's 4.18 if you can't read my ugly writing. I can hardly read my ugly writing, so let's see if I can clean that up a little bit. Okay. Plus 0.4 times the X1. What is that now? Oops. X was 2 plus H is 2.1. Okay. Now, it's calculator time. The first one I could do in my head. Square root of 4 is 2. 0.4 times 4 is 1.6. You know, 0.2 and 1.6 is 1.8 times 0.1 is 0.18. I could do that in my head. This one I can't. So, got a calculator? Anyone got a calculator here today? Please, somebody. All right. Try to punch in the numbers just like you see over here. 4.18 plus 0.1 times, open parentheses, 0.1 times square root of 4.18 plus 0.4, and I didn't square that, did I? Okay. Plus 0.4 times 2.1 squared, and then be sure you close out a parentheses. Okay? If you don't, you're not going to get a right answer.
I got 4.37, 4.38.
Okay, wait just a second. You got 4.37 or 38? What did you say? 4.38. They probably carry more digits. Keep all the ones you got on there. Don't take it off. Okay, don't delete anything. Okay? That's your new Y1. I mean Y2. Yeah.
Where did that X come from?
2.1?
Yes, sir.
Okay, remember the H is an increment of X. Your X0 was 2, and then the next one is 2.1. That's what you use to get this. Yeah, there was your H right there. So you're advancing your H is your delta X. And, I mean, think of this. This is the old Y plus the new, the change of X times dy dx, which is the change of Y per change of X. So this change of X, that's the change of X. So it was at 2, it goes to 2.1, when Y goes to 4.18. So now it's 4.38. Hang on to that. We're going to use it in a minute. In fact, we'll use it right now. Because Y3 is equal to, this is Y2, So that you got in there, leave it right there. Y2 plus 0.1 times 0.1 times the square root of Y2. If you had memory, put it in memory. So that's, I'm going to write down 4.38 just because I don't want to write all the rest of the digits, plus 0.4. That is an ugly 0. The pen is really, really slow, and I think it has it written, and it has, but I don't see it right. Okay. Okay. So 0.4 times 2, what is our new x? 2.2 squared. Okay. So if you have a memory key, store that Y2 in the memory, and recall that, or just leave it on the screen, plus 0.1 times, this probably should be a big square bracket, 0.1 times the square root of Y2, that's where you recall it from memory, plus 0.4 times 2.2, that's exact, 2.2 squared. Close the bracket you started here and hit return. And what do you get there?
Oh, so I got a little lost. I was looking at the problem trying to figure something out.
Okay. Do you have a memory key on yours?
I don't know how to use it.
Oh, okay. Let's see what it says. Memory key. I know you must have one. That's stuff that you got. Oh, there it is. Store. I think. Yeah, that's store, and then the one above is second to that. So let's store that. And I guess. Okay. Is that what you have before? Mm-hmm. Okay. Well, yeah. Solve it. Right there. That's all there is. Okay. Now, so take that number.
Okay.
That's there, plus 0.1. I don't know if you need to do it times on your calculator or not. Open parentheses, 0.1 times the square root of, and do your recall key, second recall.
Second recall.
Yeah. Oh, okay. Well, okay, square root of, and then the recall. That's the second recall. Okay. See, there's that. There it is again. Plus, oh, you might have to close out the square root, do you?
Yeah, I'll close it out.
Okay, good. Plus 0.4 times 2.2 squared. Then close out your big parentheses and press equal. What you get there?
4.59.
4.59. Okay. Now keep what you got there and put that, store that in A again. Or wherever you want to put it. That's your Y3. Okay? So Y4 is going to be Y3. So you should have it on the screen now. Plus 0.1 times 0.1 times the square root of Y3. Wherever you put that last one, recall A or whatever it was. Okay? Plus 0.4 times 2.3. You've gone up one, right? Okay, 2.3 squared equal. This one you already had there. This is your recall. If you stored that one, then recall recall this same place you had it. Should be something around 4.59. You recall it.
Give me a second, real quick. Make sure I'm typing in right.
What's that?
I said, give me a second. I'm just make sure I'm typing in right.
I don't have a calculator up here. You got one, and you got it.
I mean, I got another one. I'm just gonna use that one.
Okay. Well, but you've already got the problem started, so maybe the manual. So I don't
Still
know.
trying to know how to do this.
Huh?
I forgot mine too.
Yeah, but if you want to use this
Yeah,
other,
I don't know how to have recall and stuff.
I've been using mine now.
How you do recall again? Or unless you can just use this calculator.
no, I want you to be able to do it. I know how to do it. Did you store this one?
Yes.
Did you store it
I
in
stored it
A&M?
in there. Yeah.
Right. Okay. Then you had it on the screen here.
Yes.
Plus 0.1
Yeah.
times open parentheses 0.1
Yeah.
times the square root of recall, the second recall. Same place you had to store all this, the second.
So I just hit second and recall.
Yeah. And when you see the 4.59, is that what you see? Okay. Then plus, you close off that parentheses from your square root, plus 0.4 times 2.3 squared equals what you get there.
4.82.
That sounds reasonable, 4.82. I'm just going to write that down because you said it. This will now be your Y4. Okay? Now your Y5 is Y4, whatever you have on the screen there, you don't have to take it off, plus, and store that wherever you go, you've been storing things, store A or wherever you store it, that Y4. Okay, 0.1 times, open parentheses, 0.1 times the square root of that Y4, that's that recall, again, make sure it says something like 4.82 or something, plus 0.4 times 2.4 squared, close parentheses, equal. You're going to guess it's right around 5-ish?
Yeah, 5.08.
5.08. All right. That is our best guess at Y5, which it would be at 2.5. Okay? 5.0768. Is that what you got?
Said 5 point what?
0768 is what the book had.
Well, I got 5.076. Yeah, that's right.
Yeah, okay. All right. That was with H equal 0.1. Okay? For H equal 0.05, okay, I'm going to erase a bunch of this, okay? Oh, let's see, I didn't need to erase that. Here's, whoops, that is the part I need to erase. It'd probably be better to start with a new screen, but let me do this.
You want to ask a question?
What's that? Sure.
In the Y3,
Right. Oh, I'm sorry.
It said 2.2. But the x-axis says 4 times 2 point.
Yeah, 2.2 squared.
Yeah, how did you get the 2.2?
Okay. Every time you do a new line, this is the new y. Your x is your old x plus 0.1.
Yeah.
So it started being 2, went to 2.1 here, 2.2 here, 2.3 here, 2.4
Oh,
here.
you just keep okay.
Yeah, you're increasing it by that increment of 0.1. Yeah. See, this is your new y, that's your new x. Yeah.
In the book,
Yeah. Yeah.
Y is
Okay, but yeah.
But we had 2.4.
No, okay. That's how we got here. That would give us y5. The new x5 would be 2.5 because you went up that. You calculate it using the previous one, but when you got to here, if you had gone further, then your new x would have been 1.5. Yeah. And one lagged a little behind the other. Okay. If you
I'm asking this.
Yeah.
So technically we keep going until we get to that 2.5?
Yeah.
Oh, okay. So that one. Okay.
Yeah.
Okay.
Now, I promise you we will not do all the next one, but we're going to do a fair portion of it. We're going to do half of it because I don't have room to do it all. Okay. Okay. All right. I could do maybe a few more. In fact, I probably ought to just start over. Okay. Let's see how many we can do. They go pretty quickly once you get the hang of it, right?
Yeah. I see what you did. Yeah.
Okay. But my eraser's just not erasing very well. It just, I erase and nothing happens, okay, until much later. I guess I'm filling my cache or something like that. Good. All right, we're going to start from scratch. Okay. And again, okay. Our y0, x0, y0 start just like we were. So y1 is equal to y0, which was 4, plus this time the h is going to be 0.05. So we've got a smaller increment that's going to take us twice as many steps to get there. So we're not going to get there, but we're going to get started. So this will be 0.05 times, and your f function is still this, 0.1 times the square root of 4, same value there, so that would be times 2, plus 0.4 times 2 squared, which is 4. And this will be, I think I can do this mostly in my head, that would be 0.2 plus 1.6 times 0.05. Use your calculator. Okay. Have you already started 4?
Yeah.
Plus 0.05, open parentheses, 0.1 times 2 plus 0.4 times 1 times 0.4, close parentheses, and equal.
So I can erase the old.
What's that?
I can erase this old, the 5 points, whatever.
Yeah. You're starting over with 4 now.
All right, good.
Yeah.
Yeah.
4.09. That's exact. Okay? So store that, and your y2 is equal to that 4.09. I'll put it down because that's exact now. Plus 0.05 times 0.1 times, you stored that hopefully as y1, okay? So I'm just going to put y1, so you recall that, plus 0.4, but this time you're multiplying, okay, you're multiplying by 2.05. It was your old 2 plus your new plus your increment squared. Okay.
What is Y1?
Y1 is 4.09. So it's 4.09. You can plug it in. You don't have to store it if you don't want to.
Yes.
Plus 0.05 times open parentheses 0.1 times 4.09. Oh wait, yeah, I'm sorry. Square root of 4.09. Yeah. Square root of 4.09. I did the square root of 4 before and wrote down 2. The square root of 4.09 plus 0.4 times 2.05 squared equal, and what do you get?
4.18.
Okay, so I'll put that down, but you keep that and store it. That's your y2. Okay, y3 is equal to y2, whatever you recall, or you still have it on the screen probably, plus 0.05 times 0.1 times the square root of recall, y2, plus 0.4 times, what do we multiply now?
We multiplied 2.2.
2.10 squared, okay? And what does that give you? 4.
4.28.
28, okay? That's going to be your y3, so store that. And your y4 is going to be y3, whatever you just had there, plus 0.05 times open parentheses 0.1 times the square root of that recall, y3, plus 0.4. That's an ugly 4, okay, times what's multiplied now by? 2.15 squared, close parentheses, equal 4.38. That's your new y4, so I would store that. So your y5 is that y4 that you still have on your screen, hopefully, plus 0.05, that's your increment, 0.1 times the square root of that y4, whatever it was, recall that. Yo! Close that parentheses for the square root if you need to, plus 0.4 times, and what do we multiply it by?
2.2
squared. Okay? Close that parentheses, and that should give you your new y5. 4.9. Okay? Now that's your new y5. Now that y5 is not the same place as your other y5, because you see now you're only up to 2.2. Okay? You need to go all the way. So you got a bunch more to do. In fact, you're going to have 10 of them to do. We're not going to do them all, but I'm going to show you how you do it. Y6 will be that stored y5 that you just had on the screen, plus 0.05 times open parentheses 0.1 times the square root of that y5 that you stored, so it's recalled, plus 0.4 times, what is your new x here?
Yeah.
2.25 squared. Close that parentheses, and that should give you maybe 4.6 or so. 4.59 maybe? Guessing 4.6 something. 4.60. Okay, that's your new y6. So you get your y7, you do y6, what you probably still have on the screen, plus 0.05 your increment, times your open parentheses there, 0.1 times the square root, recall that y6, whatever it was, plus 0.4 times, what's your new x? 2.3 square it, close parentheses, equal, and you get up to 4.72. Okay, that's your new y7. Will you do that? Do the same thing to get y8, and then you get y9, and you get y10. When you get the y10, that should be your 2.50, and this time you got 5.0997 is what they got. So it did creep up a little bit. I was thinking we were overestimating, but this is indicating we were probably underestimating before. To get even more precise, you just take this to a smaller increment, and then that'll be a smaller increment too. So you keep going like that. Okay, you see the procedure?
Yeah.
Okay. Takes a lot of time, but once you get the groove of it, it's pretty straightforward. But remember, what you're doing is, here is your y prime. This is the differential equation. That's your, what they call your alpha vector. That's what your change of y for change of x is. That thing right there. You're starting with an x here, okay, and a y there. So you plug that in here, those values in here, and that tells you how much your y is changing. So do your previous y, which was 2, plus the change of x, that's your h, times your change of y per change of x, that gives you, change of x's cancel out, that gives you your change of y. So your old y plus your change of y, that gives you your new y. The new y then, plus the change of x, times this, but with the newer x's and y. X went up by 0.05, your y went up by whatever it did. So that's the change of x, and this is the change of y per change of x, so that's how much y is changing here. And then you do it again. This is your previous y, your change of x, the change of the y with the previous value and the previous x value, and for change of x cancels out, that gives you change of y, add that to this, that gives you your new y. Like that, and you just do the same thing over and over again. You're stepping up 0.05 in x and whatever y that gave you, and just keep crawling from there, okay? And you finally get something. They got about 5, getting awfully close to 5.1. Okay. Now, I just stopped because I didn't have room to write anymore. Okay, let's clear that screen if you're okay with it. Okay. Now, example 2 here. Consider the initial value problem, y prime, point 2xy when y1 is equal to 1. Y of 1 is equal to 1. It says use Euler's method to obtain an approximation of y at 1.5 using first h equal 0.1 and then h equal 0.5. So what we're trying to get to is y of 1.5, and we'll first use h of 0.1. Okay. Now, one kind of advantage to doing this one, that last one we had there, did anyone want to try some method to solve that one? It wasn't separable, the previous one. Wasn't separable, it wasn't linear, it wasn't exact, it wasn't Bernoulli, it wasn't anything that I can think of. It was just a really tough differential equation, and that basically is what now. This isn't the best method, okay? This is a method, sort of obvious first attempt at a method, okay? This one, however, we can solve by separation of variables. We have solved it. We are going to do this method and see how we compare, okay, with what our exact would be. It's not an exact differential, but when we do it analytically, okay? So where would you begin? Y1 would equal, this is your x sub 0, this is your y sub 0. They both happen to be 1 now, so there's plenty of things. So what is our procedure? y0 plus 0.1, that's your change of x, times this thing here, 0.2 times 1 times 1, x0, y0. Okay, this should be pretty easy to calculate. This y0 is 1. Let me go on and write that down. I was going to write down the thing, but I thought we know it now. Okay, 1. So, if I'm seeing this right, that would be 1 plus 0.02, right? So that would be 1.02. If I did my calculation right, that's what we've got. Yeah. Okay. So then the next one, y2 is equal to 1.02 plus 0.1, that's your h, times 0.2 times, my new x is 1.1, and my new y is 1.02. Okay? I'll need a calculator for this one. So, punch this in. 1.02 plus 0.1 times 0.2 times 1.1 times 1.02.
1.04.
1.04. Okay, store that as that's your y3, y2. Okay, so y3 is equal to the y2, what you just had, plus 0.1 times 0.2 times your x is now 1.2, and your y is that y2 that you just stored. These are easier calculations too, so it should go a lot quicker. The recall of what you just had. 1.07, yeah. 1.067, so I'll put 67. That's your new y3. So your y4 is that y3 that you stored, hopefully you did, plus 0.1 times 0.2 times what's your new x? 1.3, and your new y, whatever that was, that you just stored, what does that give you? 0.9 maybe? Yep, or maybe 1, 0.
1.10.
Yeah, got it. So that's your new y4. Okay? y5 is equal to that y4 that you just had on the screen, plus 0.1 times 0.2 times what you do, x, yeah, 1.4, and then your y4, you plug that in, recall that, about 1.12-ish or so,
Yep.
or 1.13. And that's your good guess for what y5 is, at 1.5. You started at 1, and every time you went up by 0.1, so you're now at y5. So that's what our guess is here. Now, if you do 0.05, okay. Okay. All right. Oh man.
One question.
Sure.
Why did you stop at 1.4?
Okay. Now I stopped at y4 and we did y5. So that's why I knew it. Okay. y0 was at 1.
Yeah.
Right? At 1.0. You know, at x equal 1. And that gave you y of 1. So y1 was at 1.1 because you went up by 0.1.
Yeah.
y2 was at 1.2, y3 at 1.4, y4 at 1. Whatever I said. y3 at 1.3, y4 at 1.4, and y5 at 1.5. That's what it said. Yeah.
Okay, I was just looking at it wrong.
The last x you used was the 1.4, but that gave you the y5, which was at 1.5. If you had gone the next step, you would have calculated y6, which would be at 1.6, using 1.5. Yeah. But you were already past what you were gunning for. Okay. I think I've got one more thing to erase. Okay. So, this, one more. 0.5. All right. You have your same y1 of 1, so that's all the same. So it's 1, that's your y0, plus 0.05 times the 0.2 was the same, 1, 1. So that would be 1.1, 1.01, right? Right, okay? So I'll put 1.01 because that's exact, okay? All right, plus 0.05 because that's your new increment, 0.2 times 1.01 times, whoops, that was the x. It doesn't matter. I was going to put it in the other place, but just to be consistent, the x is 1.05. And this is 1.01. Okay. 1.01 plus 0.05 times 0.2. Huh?
You'll get 1.02.
1.02 approximately. Right? Yeah. With some other digits there. So now you'll do your y3 will be that y2 plus 0.05 times 0.2 times 1.1 now. X goes up by 0.05. Whatever that y2 was, and what do you get? Hey, 1.03. Okay? And then that's your y3, so your y4 is going to be that y3 plus 0.05 times 0.2 times 1.15 times whatever that y3 was, and that's equal 0.04. Okay, that's your new y4. Store that. y5 is going to be that previously stored y4 plus 0.05 times 2 times 1.2 times y4. 0.06. That's going to be your new y5. Okay? So y6 well, wait. I'm starting to write down what you said, but it's so much easier to just write y5. Plus 0.05 times 0.2 times 1.25 times y5 equal
1.07.
Goodness, my writing stinks. Alright, and that's your new y6. So your y7 is going to be that y6 plus 0.05 times 0.2 times 1.3 times y5, y6, sorry.
And it will equal to 1.08.
1.08. Okay? Yeah. Alright, and your new y8 is equal to your old y7 that you just calculated, that you stored hopefully. Okay, plus 0.05 times 0.2 times 1.35 times y sub 7. 1.1. Okay. No, 1.1. I can't get that to work. Okay. But you say that was 1.1. 1.1. Yuck. Okay. And you keep on going. And the last time we got up to, and this table actually shows the actual value. 1.1331. Last time we showed 1.1259, a little short. This time we would, if we had continued, get up to 1.1259. And whereas the actual is 1.1331. So we're getting closer. Ever so slowly, but getting closer. Okay. Now, so consider the initial value problem, use that, and then that. Okay. While the identification they talk some here about, okay, perhaps we should do the absolute value. I mean the actual value, not absolute value. Okay. I hate to erase all this again, but I think I will. Okay. Well, this thing is so slow. Oh, there we go. It'll just erase it all. Okay. From our one that we had before, I'm going to rewrite it. dy dx is equal to 0.2xy. Okay. So I'm going to write it in differential form and divide by y at the same time. dy over y is equal to 0.2x dx. You could put the 0.2 with on the other side, but it's dividing, which would actually not be too bad. But this is usually the better way. Integrate both sides, and what you get is log y is equal to 0.2 x squared over 2, right? Okay, which would be 0.1 x squared. So you could put a plus c there if you want to. I think I would do y is equal to e to the 0.1 x squared plus c. Now they probably put the c somewhere else, but let's plug in 1, 1. That was our initial value. So 1 is equal to e to the 0.1 times 1 squared is 1 plus c. So it would be c is approximately equal to 1 minus e to the 0.1, 0.1. Okay, plug that in and see what you get. It's not an exact answer, but it's they use computer software. How nice. Well, let's see. That is one way to do the answer, but they write it also like this, and since they got it there, I'll do it. Y is equal to e to the 0.1 times x squared minus 1. Okay? Now, that's exact. That is our solution. And if you plug in x equal 1.5, that's what we were looking for. So y at 1.5 is equal to e to the 0.1 times 1.5 squared, I think is 2.25, isn't it? Minus 1. So that'd be y of 1.5 is equal to e to the 0.1 times 1.25. So that would be e to the 0.125. So see what you get. E to the 0.125. That doesn't seem right.
1.13.
1.1331, right? Yeah. So that is what you get. And so we've shown that. Now, we'll round that to 1.1331. That's the exact value at 1.5. Now, when they talk about errors, the absolute error, and this is, when they say absolute, they mean no signs with it. Just what's the difference between what our value is, 1.1331, and what are calculated by Euler's method. The first one was 1.1259. And what's the difference between those two? 0.0, let's see, that would be 2 here, that would be a 7 there, and this would be a 0.0072. They got 7.3, okay? That's the absolute error. What's the relative error? Well, the relative error is the absolute error divided by the actual value, okay? So it's this thing divided by 1.1331. So plug that in and see what you get. And then they multiply by 100 because that gives you a percent. The 0.007, they use 7.3, I was using 7.2, divided by 1.1331. That was the actual value. What does that give you?
That would give you 0.00635.
Okay, you move the decimal 2 places, multiply that by 100, you get 0.635.
Yeah.
They got 6.4. Yeah. 0.64. So that was the percent relative error. Okay. Now, let's go to our table we didn't do, the 0.05s, and we got up to 1.1295. Okay, and the difference between those two is 6.300. Our absolute difference is 0.0036. Our percent error was divide that by 1.1331, and you should get about half of what you did before. Why didn't I write it down? 0.64, this is 0.32, exactly.
What was it, 32?
Yeah, if you do this number here, 0.0036 divided by 1.1331, because that's half of this, then the percent error is going to be half. That was 0.64, so that was going to be 0.32. So it's a pretty small percentage error. Pretty small. Okay. All right. They have what they call a caveat here. Euler's method, whoa, we're out of time, aren't we? Sorry, we got started late. We'll start next time with the caveat. Not a very major one. Sure, wasted a lot of time today doing those, but I thought it was good for you to go through at least one or two. Okay, we'll start with the caveat. And by the way, yeah, we'll hit that next time. So homework exercises here. Do number 1, do number 3, do any of the odds 5 through 9, do number 11, and then once we finish this, and we basically are almost through, did I give y'all copies of the next test yet? Do you want them today or want to wait till Wednesday? Okay, want the second test today or wait till Wednesday? We're not through with the chapter yet, but yeah. What?
It don't have to be.
Okay. I'll have to run them off, I think. I don't think I have 3 run off already, but let me see. There's test 1, test 1. I do need test 1 back from anyone who hasn't turned it in yet. Goodness gracious. A lot of junk here. Here's test 2. There's test 2. There's test 2. No, I don't have them run off yet. You want me to run them off and get them to you, or you want to just pick them up next time?
We can go next time.
Okay. All right. All right. Good deal. We will end this now.